are apparently recording. There we go. All right, cool. So yeah, Doug, if you can, at some point we'll have that conversation again where you describe how you're doing that, because like I said, I'm not a Git person. I mean, I use Git, but I'm not. It's not kind of in my bones the way programming is. So.
Well, it isn't in mine either. I use it, like you said, and every time I use it, I have to learn again. You know what I mean?
Yeah. You're an XKCD Git user. They have the best Git meme on the planet.
Yeah.
All right. So we are here this morning to talk about a project that I've been working on called the Universal Robot Configurer. Oh, I shut it off. It won't come on with the screenshot, or the screensaver won't come on when this power's off. Yeah, so this is a nice little wearable device. It has a 1.28-inch round touchscreen and a battery and a 3D printed case and a whole pile of code running on it. And the idea is behind this is it's not a controller. I mean, you could probably use it to do that, but that's not what my intention is. My intention is to allow you to configure robots, because most robots don't have a user interface. They don't have reasonable ways to interact with them. You know, like I take an example, my quad walking robot, Roz, it has a Raspberry Pi Zero. And when I bring it to a meeting or something like that, in order to use that, I have to get that Raspberry Pi Zero on the local Wi-Fi so that I can take my laptop and SSH to it. And that means you basically have to hook up a monitor to it, or, you know, get a serial terminal somehow working on it and fiddle with text config files and stuff like that. And it's just a pain in the butt. So the idea behind this is it allows you to configure robots, and this has an ESP32 in it, and ESP32s have this neat feature called ESP Now, which is a peer-to-peer based networking system that basically allows you to communicate between two devices without knowing anything other than their MAC addresses. And there's no pairing or setup or anything like that. It basically works like a network-enabled UART, really fast network-enabled UART. So anyway, enough of that. That's the URC. So I'm going to do a deep dive on the code today, on the architecture, talk about how this thing was built, and oh, cool, you got one there. Nice.
What is that, Mike?
You're muted, Mike.
Oh, it's my development setup. So this is like the tiny
it's a seed Zao. Yeah.
Huh?
It's a seed Zao
with its antenna.
Oh,
So I can put this on the robot itself and put this one on the watch.
cool.
So that's my little development setup.
Yeah, I have, you know, this is the same chip, the
same device.
Yeah, and of course the round board. Yeah, so today I'm going to talk about architecture and coding and how it is. You're muted, Lewis, if you're talking. Okay. All right. So I'm going to share my screen. Share my screen so you guys can all see this. And that go away. Okay, so you guys can all see this editor. Yes, I can't see anybody right now because I'm looking at the editor. So
yeah.
Okay, so this uses MicroPython. MicroPython code running on the ESP32. It has a main.py like every other MicroPython program. The basic, well, I guess I should back up a little tiny bit here. The basic architecture of this thing I just discuss on my GitHub page here, where I talk about this. But the main idea here is you have a few different things. You know, from a class perspective, you have a display, which represents the you know, the visual component of this. You can draw to the screen, the physical screen, using the display class. The touch manager is the sort of the opposite of the display. It's the input side of things. It basically uses an I2C connection to talk to a specific chip that is on this piece of hardware and allows you to get interrupts in XY locations of where your finger is. This whole thing is based on a windowing system, and a window in this system represents a single you know, display on the screen. So it's basically all the windows are full screen and they're all modal, but it basically, you can add things to the window and display buttons and labels and lists and all kinds of things. So, you know, you get the 240 by 240 pixels, and clients, what I call clients, which are really the code that you write for your robots, can create windows. The window manager is the guy who manages the whole user interface. He manages talking to the touch manager. He manages talking to the windowing system, to the windows themselves. And it has a specific, there's two specific mechanisms that I use for navigation. The first one is called a window chain. And you can think of a window chain. I'm going to switch off presenting here for a second so you can see. So this screen here, you can see those little blue bars on the sides. Those indicate that there's a window chain here. And what a window chain is you can think of it as a series of windows that are chained together horizontally, and you can scroll between them by sliding sideways, and it switches to a different screen. So in this particular case, this goes from the theme chooser window back to sort of the root window, the universal robot configurer window. So you can have as many windows in a chain as you like. You know, there aren't really any limits other than it gets painful to be constantly scrolling. And when you scroll, it's like literally like a chain in that it's connected on both ends. So if you scroll in one direction, you'll end up back where you started again, and same if you go the other direction. The second metaphor that I use is a stack. And we have a stack of window chains. So the window chains run, think of them as running horizontally. The stack runs vertically. So this is sort of right now at the top of stack, it's the only thing in the stack. But when I touch this button that I have in the middle, it pushes a new entry onto the stack. So that window is now down one level, or you could think of it as up one level, depending on how you think about it. So this is another, and you can tell it's a window chain because it's got those little horizontal sliders, but it also has another slider at the bottom, which is the vertical slider. And that indicates that you can go back up the stack by sliding up. So, well, so I go like that, and it pops that entry off the stack, and you get the last thing that was on the stack. So I can push that to go down, and then this window chain, I can go sideways. And in that case, I accidentally hit it twice. So now I'm down the stack on Roz, my walking robot. So those two metaphors are basically how you build up a windowing system for your robot. So you will have, you know, one or more robots that you'll run, that you'll talk to with this thing. And the way that I've designed it is, I basically have a window chain that contains an entry for each robot. And then if you touch the robot, you go down into that robot. And then there can be, you can have like this one does not have a window chain. It's just got 3 buttons that basically allow you to push another window that you can then slide up to get back to here again. And so those 2 metaphors give you a lot of flexibility in terms of how you can lay out a user interface. So we'll jump into the code here. And
So you can have stacked items below any item in a chain?
yes, yeah, each item in the chain can have its own stack, basically.
Perfect.
Although
Thank you.
they're kind of created, the stack. Okay, so a window chain, you create all the windows ahead of time and you just slide between them. When you push something on the stack, that's a new window. It doesn't matter, like if you go back again and then you drop down into that one again, it's a new window each time. When you pop something from the stack, it goes away, never to be had again, that particular one. It builds a new one when you drop down into the stack again. So this is what this main program looks like. I basically create a new instance of failsafe, and then I sit in a loop and do nothing, basically. And that's one of the fundamental precepts of this, this whole design, is that everything is event or interrupt based in this, from my perspective. How you write your code forward is another question, but all of my code is event and interrupt driven. So there is no main loop. The main loop just sits and idles. Everything in this user interface is driven from touch interrupts or timer interrupts that happen asynchronously. So we create a new failsafe, and if you look at failsafe, this init is the underscore init is the constructor for this class. So this gets run. We create the display. That's my little class that interfaces to GC9A01, and GC9A01 is this is Russ Hughes' driver for this board, which includes graphics and well, he doesn't actually include a touch interface, but he shows you how to use the touch driver. So this is basically, display is my class that interfaces with his class, and his class is all effectively written in C code. So basically you create it. It creates an SPI connection to the port, and it sets up various pins, MOSI and serial clock. It sets the baud rate, you set the backlight pin, and then you create a screen object, which is one of these things. And then I provide a few front-end functions for drawing various things, but most of it you can just ask for the screen. You can ask the display for its screen, and then you can get access to all of the graphics libraries that he provides in his driver. So main.py, we create a display, and then we create a window manager, and the window manager gets the display as an argument. So the window manager has the display, and then I build these specialized objects, which are the 3 windows for the 3 robots that I have. And they're not really windows per se in terms of my window. They're like whole window trees. So the rover, the RAWs, and my tabletop robot. So each one I pass in the window manager and the display, and then I build a chain, which is this guy, based on these 3, and these actually are windows. And then I push the window chain, basically. Well, actually, I build the admin, and then I window chain and push it. And so basically what I'm doing here, this guy, the admin window is the thing that displays the, at the very top level, that displays universal robot configure with the battery voltage, and then you can scroll right to choose the theme. So that's the admin window chain, and this is sort of the robot window chain. So I'm actually building both of them at the same time. It doesn't really matter how you do it. I could build these once you click on this thing to drop into that chain, or you can build them before. It's kind of up to you. It doesn't really matter. I try to show different ways of doing things in the code, which means I'm not always consistent with where I build things and how I do things, because the system's really flexible. You can do things almost any way you like. So that's basically it for admin, or for main. The admin window, where is the admin window? Is right here. So basically this is the very first window you see here. Okay, so a window is composed of views. And in this case, I only have one view that I add to the window. And a view, you can think about a view as sort of a geometric construct that has an origin and an extent. And those are points on the screen. So in this case, I have a point at 40,0, and I have a point at 160,240. And so if you think about that, that's a 120 pixel by 240 pixel sort of vertical rectangle that covers sort of a more rectangular part of the screen. And then I'm going to display on that, I'm going to add to that view some visual components. And there's a bunch of different kinds of visual components you can create. You can create labels, you can create buttons. So this is a button, even though it's invisible, but it is a button object that you can create and add it as a component. And everything is done with callbacks to go along with sort of the whole interrupt and event-driven thing. So I am registering, I being the admin window, I'm registering, I want to get notified when this window is activated. And I want to get notified when the window is about to be closed. And the reason for that is if you look at the window activated function, which is down here, I actually create a timer, a hardware timer, so that I can update that little display that shows the battery voltage. So I set up a timer, it's periodic, it's frequency of once per second, and I call update battery, which is this function up here. So that gets called by the ESP32 hardware once per second. And basically what I'm doing is I'm going to go and grab the battery voltage from the A to D converter. I'm going to set the color of the label based on where the voltage is. I'm going to set the text and the color based on that. And then there's a little trick I'm using. If the battery voltage is greater than 4.3 volts, that means I've got a USB plugged in. So I'm going to add a little charging indicator to a label that's there. Otherwise, I just make it empty. So this is kind of a interactive piece where, you know, I basically created, if you look at the sorry, can I get back to here? If you look at the screen, you can see it's got 3 labels that are in yellow, and then it's got bat in blue, and then it's got a box with a number in it, and that's also a label. It's just a label with a box around it. And then there's a one extra label, if you plug in USB, you can see it added a little red thing there that says charging. And that just goes away if I unplug it. And so it's a very simple window with a callback. I register the callback on activate and close because I need to start and stop that timer. I don't want the hardware timer running when this screen isn't on. So I have to be, you know, if you flip over to this screen, to the theme screen, I don't want to show the battery voltage on the theme screen, so I don't want that hardware timer running. If the screensaver comes on, I don't want the hardware timer running. So those are the kind of the places where you would use activate and close to turn on and off hardware timers and things that you're using to update the display. And we'll see that more a little bit later when we get to actually the telemetry display. If you guys have any questions, feel free to jump in and interrupt and whatever. If I'm going too fast or this is you need something described a little better or whatever, feel free to interject. Okay, back to sharing the screen. We'll look at some more code. So that's the admin window. Now I'm going to show you a specific window, and in this case, this is RAW's window, which is the window that when you touch, as you recall, there's a window chain underneath that with the 3 robots, and if you touch the robot, then it jumps into this. So this is kind of the root window of it, and it has a different kind of visual component. In this case, it's a JPEG image. So I create a view, you know, I've got the window, I create a new window for this thing. I create a rectangle to represent the entire screen. I create a view on that rectangle, and then I add that, and then I create a JPEG image. And inside the robot, you can see here, it's actually on here as well, RAW's robot. So this is the picture that I show on the screen, and it's a rectangular picture, obviously, because that's what they are, but it shows you this as if there was a circle imposed on this. This is a 240 by 240 pixel image, and it's not very big. It's only like 5 or 10K. So I create a visual JPEG image based on that, and I add it. And then I also create an invisible button, so when you touch the robot, it will call, and I register a click handler for that button called Open Rover Window. And that's it for that window. This is the entire definition of the window right here. It's very simple. You create a view, well, you create a window, you create a view, you add component, well, you can create one or more views. The other thing that I didn't say about views that I probably should have is a view allows you to set aside an area of the screen, and then the components that are in that view are relative to that view. So in this case, the view origin is 0, 0, so that doesn't really matter. But if we go back to the admin window here and look at the view that I created, that was at 40, 0, right? So that's like 40 pixels over from the top left corner. So now when I add components, and I add this component and his X value is 0, what that really means is his X value is 40, because it's this plus this. So these labels, because I'm adding them to main view, are all relative to this location, which can really be anywhere on the screen. And you'll see that when we get into more complex views. I have a sort of a standard 3-view layout that I use for a lot of these things. For some of them, I don't do that, but a lot of them I do. So going back here. So that's it. That's all you need to do to build a window, is you create a window, add a view, add one or more components, and register handlers for them, and then you're done. And so in the case of when you actually click, when you touch the robot picture, you're touching this guy. When you touch it, it calls open rover window, which is this function right here. And that basically says, okay, well, we're just going to create the RAWs. We create an instance of RAWs choose window. And funnily enough, that's right here. And in the constructor for that one, I set up my window manager and my display. I build a window, which I store in choose window, an instance variable of this class. And then I tell the window manager to push that. And that's all there is. Boom. Now we've got a new window. We basically pushed a new window onto the stack. And this one with the picture got pushed down the stack. So it's one level below us now. So build rover choose window is a slightly more complex window. So once again, we create a window. We create, in this case, 3 views. We add them to the window, each view. And then we create labels and buttons and add them to various views. So in this case, it's very simple. I have a top view, which is from 00 to 240, 58. So that gives me the full width of the screen, but only the first 58 pixels. And then the middle view is kicked over 40 because, you know, that whole top left corner, you can't see it on this screen. It's a round screen, so you can't see it. So there's no point putting buttons and things over there because you can't see them. So that's why this middle part starts from 40, 58, and it's 160 wide and vertically high enough to go down to 182. And if you add this and this, they equal to 182. So this bottom view is basically a mirror of the top view. It's 58 pixels high, but it starts at the bottom instead of at the top. So I add these 3 views, and then I create a few labels. The first label is the word RAWs, and one of the attributes, labels have a few different attributes. The first one is a point or a rectangle, describing, and if it's a point, it just describes its location on the screen, sort of the top left corner. If it's a rectangle, you describe the box that it's going to show in. The text that's going to show up in the label, and that can either be just a hard-coded string here, or you can have, you know, a variable that has that changes or whatever. The font is important. So in this whole system, I have 4 different fonts, and you can ignore these underlined things. It's just because Visual Studio doesn't know about the fonts that I've baked into my firmware. But I basically have what I call font 15, 20, 25, and 32. And these are all, well, 32 came with the driver, and then I built these fonts basically from the TrueType font source in different sizes. So we've got, you can think of these as the font height. So 15 pixels high, 20 pixels, 25, and 32. And so when we create this guy, this is the label at the top. Well, that's big, so it's going to be my big font, 32 pixels. You know, as you recall, we've got 58 pixels to play with, so 32 fits in there, no problem. Sorry, was somebody asking something, or? Okay, guess not. This value is a Boolean that says whether or not this label should be centered on the screen. And that's why, because it's true, I ignore the X value of this, and I basically compute the width of this string using this font and pick the center basically and draw it so that's centered on the screen. And then all of my components, this is the color that we use, and this is based on the theme system, which I'll get into in a little while. So basically, create a label, throw it in the top view. And now I'm going to create a few buttons, and those all get added to the middle views, the middle view. So the middle view button Y starts at 20, but it's not really 20. It's 20 plus 58. But I'm just thinking about it in terms of the middle view. As far as the middle view is concerned, it's 0 at 20. So I create a rectangle with that origin and this extent. And here's the text for the button. Here's the font that I use and the color. And then I basically tell the button, hey, let me know when you get pushed. And when you get pushed, this function gets called. When this button gets pushed, this function gets called, and so on and so forth. And so these are all kind of boilerplate type things. You know, all of these look identical except the label and the Y component of the position of the button. And I'm just start at 20 and then I add 40 each time to add this new button. The buttons are 35 high, so that gives me a little bit of space between them. And that's it. And you register the click handler, and when you click on that button, well, it runs this code. Right now, the sensor and the servos code, I don't have those windows done, so they don't do anything. But the mission window is there. And so if you recall up here, you know, when we had open rover window, we just said RAW's choose window. So create a new instance of that guy. Well, I'm doing the same thing here. I'm creating a new instance of the RAW's mission window, passing the window manager and the display, because all these things have to have those. And once again, we build the main window, create a window chain in this case, because I've got a few missions and I want to be able to slide between them. And so this is one way that you can create window chains, basically just loop over a collection of, in this case, a list of labels and create an actual window object and append it to that list. And then I can basically create a window chain from that list and push the window chain, ask the window manager to push the window chain. So I'm calling the same function, except I'm passing in the mission name as an argument. And so I create the window, create the 3 views, add the views, create the labels that go in. So I've got a top view, middle view, middle view. You know, the top view is, because this is RAW's, it's the same label as on the previous window. And then I have an information label to say which mission I'm in. And then I create a couple buttons, one for run and one for configure. And once again, it's all the same stuff. You know, you register a click handler, and in this case, I'm passing an argument to the click handler, which is an optional thing. And if you do that, then when it calls your callback, that argument will get passed in. So in this case, you know, I've got 2 missions, wander and quick trip. So it'll call run mission wander or run mission quick trip, one or the other. And right now I'm not really differentiating between them. But once again, you click a button, you create a new set of windows, except I'm passing in the mission name this time because we have it here. And so now this is the interesting one. And I'm going to stop sharing here for a second and show you this again. So this is the picture of RAW's. You touch it, it goes into here. We've got the label at the top, the 3 buttons. I'm going to click the mission button, and then I get RAW's and the name of the mission, and I can shift between quick trip and wander. And then I'm going to click run, and you can see there, that's my sort of telemetry window that's running, although I'm not getting any telemetry because I don't have anything pushing data to this. But you can see that it's basically just a bunch of information, and I'll show you this. And if you click on here, because this is a walking robot, it doesn't require a fail-safe. So I just touch the screen to start it. So it's running. Geez, I wish this thing would focus. And you can see there's a little timer running on the side there. And then you can touch it again to pause it, and that stops, and so on. And so this is a bunch of information on this window. And now I'll show you what the code looks like to create that. So that is a run mission window. And so once again, in this case, it's a little bit more complicated because I don't want all of this information about the mission to be in the window. It's kind of the wrong place to do it. I should have an actual mission object. And so if we drop down here and look at Raw's mission, so it has a mission name, it's got a paused flag, you know, it's got the runtime and runtime tenths or tenths of a second, the URC voltage, the battery input, because I want to display that on the screen. And then this is the information that I'm going to get over telemetry. Basically what obstacles are out there, which navigator is active, what the current state is, target position, target name, position, heading, my position being the robot's position, what heading he's on, and the voltage of his battery. And so the mission keeps track of that stuff. So I just build a mission object and stick it in the window here. And then we build the main window and we're just going to push it. Now, one of the things that we want to do, because of the fact that we're running a mission here and we are, you know, getting telemetry back from the robot, I don't want the screensaver to kick in after 60 seconds, which is what it normally does. So I tell the window manager, hey, disable the screensaver. And so as long as this window is running, we want the screensaver disabled. So that the screensaver will never kick in if you're on this window. And then I create an update timer, exactly the same way I did with the first window. It's timer periodic. In this case, I'm running it at 10 hertz. Actually, yeah, this was a frequency number. It's not a time. So I'm running it at 10 hertz as a frequency, and my callback is self-update. Okay, so we'll get back to that in a minute. And then I built this telemetry object, which I'll also show you in a few minutes. And this is the MAC address of the robot itself. And then I'm going to register a telemetry callback, which means basically whenever the robot sends me data, I want to get that data in this function. So we'll go over that in a minute, but let's build the window first. So standard stuff, build a window object, build the 3 views, add the 3 views, and then we're going to create a bunch of labels. So in this case, I've got, these are all labels using font 15, which is the really small font, because I'm cramming a ridiculous amount of information into one screen. And almost all of them are, not all of them, but most of these are centered. A few of them aren't. So the ones in the top view are not centered. Well, most of them are. So paused and then this are both at Y value 20. So this one's at 55 and this one's at 135. And you know, you basically just have to play around with these numbers to get them to fit. So I'm basically creating a label, except instead of passing in a point as the origin, I'm actually passing in a rectangle this time, because I want it to draw this label and I want it to take up this much space. And whenever this updates, it basically erases this entire space and then redraws it again. Whereas if you just give it the origin, it doesn't know how big the label is. So, you know, if you then say P instead of paused, then the AUSED doesn't get erased, and you know, you end up with funny artifacts on the screen and stuff. So you can pass in a rectangle as a visual label position, and that will basically erase the entire rectangle. In this case, it's 75 pixels wide and 20 pixels high. This is an origin, this is an extent. So false, it's not centered, it's in this color, this is the foreground color, and this is the background color. And so we add that, and I actually keep this in an instance variable, self-running label, and we add it as a component to the top view. And then we have this other one, which is the timer. And that starts, so 55 and 75 is 130. So this guy actually starts at 135. And he's also starting at the Y value 20, and he's 50 pixels wide. And so it's basically a minute and second timer. And all the same stuff here. The obstacle label is just obstacles, and that one's centered, and it gets added to the top view, and then these guys all get added to the middle view. So there's 2 lines on the top view and like 5 lines in the middle view and 2 more lines on the bottom view. And so they're all basically labels that I've created using, create this label, foreground color, background color, here's the label, here's where it goes, all that jazz. And we want these all to be in rectangles because we want them to erase the background as we get new values. And that's why I pass in a rectangle instead of just a point, even though they're labels. Because when we get new values in for these things, and I'll show you how that happens, we want to erase whatever was there before. And same thing with the voltage. So basically we've added a whole pile of labels to the 3 views, and then I create an invisible button which covers most of the screen. Well, it covers the middle part of the screen, and that's my pause toggle. So when you touch the screen, it pauses, and then when you touch it again, it resumes. And I want to know when I'm about to be closed so that I could turn off that hardware timer that I created up here, and disable the, shut down the telemetry. So I want to know when I'm about to close. So that's where we register about to close. So the pause toggle, as you recall, is the click handler for this big invisible button. All it does is I tell the mission toggle paused, and that's basically down here. It just says self-paused equals not self-paused. Very simple. And then I send that message. I send a packet over the telemetry system of what the current status of the mission is. I ask the mission for its mission status packet. And in my case, a packet is really just a JSON string. In this case, it's a dictionary. So I say return JSON, dump this string, or dump this to a string, and I've got a dictionary. It's a mission status. It's paused, true or false, and it's this mission. So it basically sends this dictionary in string form, in JSON form, to the other ESP32 on the robot, and that's it. And then the other thing that happens with this, as you recall, way back here at the beginning, we registered an update timer at 10 hertz, which calls self-update. And self-update does 2 different things. It asks the mission to update, and then it updates the window. Mission update, where is it? There it is. So it's basically running this counter, and every 10 times or once a second, we go and update our voltage. So basically get a new voltage from the URC and update it inside the mission, because the mission wants to know what the voltage is of this thing so we can display it on the screen. So that's it for the missions update. It doesn't do anything interesting. Update window basically takes the values from the mission and sets them in the labels. So in this case, so let's see. Pair. So this is the color. So if you recall, on the screen there, and I'll stop sharing here for a second so I can show it again. It says paused in the top corner there in red. And when I touch it, it changes to running and it's green. And it's really not focusing very well on this, but you can certainly see the color that it changes between there and there. So I basically ask the mission, are you running? And if you are, then tell me, you know, both what string I should have and what color it should be. So I just return you know, this is just a tuple in Python. If we're paused, then return paused and the alert label, which is really red. And if we're running, then it's the good label, which is green, if we're not paused. And so I use that in update window to take the running label and set its text and set its color. And so that's one of the methods in label, and I'll show you that in a bit, that you can...
I'm not seeing your code.
Oh, I forgot to share again, sorry. Boom. Whoops. Thanks for letting me know. Okay, you guys can see again. So we basically get the running string and the color, and then we set the running label to be those two values. So we set the text to be the first value, which, as you recall, was the string either running or paused, and we set the color to be the second value, which is either red or green in this particular case. And the timer label, so basically the mission has a bunch of methods in it that answer values for all these labels. Okay, so every one of these labels, the timer, the obstacle, the nav label, the state label, the target label, position, heading, voltage robot, you know, the robot voltage, the URC voltage. The mission has values, has methods that return each of these. So the target heading is my position and then compass heading to the target position, because, well, I guess I should show you what the telemetry packet looks like first. So before we get into that, if you recall way back in the beginning when I set up the telemetry, I said register the telemetry callback, get telemetry packet. Okay, and get telemetry packet, you get this packet. Well, I'm just going to pass that off to the mission and say, hey, here's a new telemetry packet, and I'm going to be getting these at, you know, whatever frequency I decide is reasonable from the robot's perspective. It might be 1 hertz or 5 hertz or 10 hertz or who knows. It doesn't really matter. So basically, the telemetry system will call this method when it has a new packet, when it gets a new packet over ESP now. And so the mission process telemetry packet method basically is getting back a packet that is a dictionary in Python. And so if it includes the key RV, then set the robot voltage to that value. If it includes heading, then set my heading to that value. If it's the position, then there'll be 2 elements, an X and a Y, and I set it to be a point. This is the target position, so I'm going to set the target position to be a point, X and Y. And the target name and the navigator and the current state and what the obstacle picture looks like, if you like. So this is all things that I get in the telemetry system from the robot. Whenever it sends me a telemetry packet, this method gets called, and we just store it in the mission. So the mission object gets updated from the telemetry packets. Okay, so then when we call these things, when we call the update function for the window, then we can basically compute things like, what's the target heading? Well, the target heading is the compass heading to the target position from my position. What's the target range? Well, it's the distance to the target position from my position. You know, if the target name is blank, then I'm going to say no target. Otherwise, I'm going to say that it's the target name followed by the range at this angle, this compass heading. So I'm basically creating these sort of complex strings that contain one or more pieces of data that we got from the robot and that we compute based on our values. So obstacles is pretty simple. Position is X at Y. The state string, it's just, those are just straight strings. Robot voltage or floating point, URC voltage is floating point. So basically the mission, you can think of the mission as an object that keeps track of what's happening with the mission and the robot. And it's updated from the telemetry system, from the other ESP32, and it's displayed on the window by updating, and the update gets called 10 times a second. And we call set text, and sometimes we call set color, depending on what we're doing, with these strings that we've gotten either directly or derived from the telemetry packet that we got from the robot. Does that make sense to everybody?
Yep.
It's pretty good.
Yeah.
Oh, yeah. Well, John, I have to head out to a rehearsal, so thanks for the info.
Okay.
All right.
No, like I say, this is all getting recorded, so you'll be able to watch it later.
All right. All right. Bye.
See ya. Okay, so that's how we do that, and you can see, you know, the telemetry is really two-way. We get telemetry from the robot, and then we also, on occasion, send telemetry to the robot, or not really telemetry. You're sending a command message to the robot. So when you click the pause button, we send the mission status packet. You know, we toggle paused in the mission because the mission is the object that keeps track of everything to do with what's happening with the robot. And then we basically tell the telemetry system, hey, here's a string to send to the robot. And the string is formatted such that it tells it what type of message it is and the contents of the message. In this case, it'll be paused, true or false, and the name of the mission, just as useful pieces of information. One of the things that I like to do is, even though it takes up a little bit more space, I like to try and make my data at least be a little bit human readable, so that you can look at these things. You know, if I log these telemetry packets in the robot and to like an SD card or something like that, then later on I can bring those up in you know, even just in a text editor and look and say, yeah, okay, well, this is all for this mission, and you know, it's paused true or paused false, and you know what kind of thing it is and stuff like that. So I find that really helpful when you're debugging, to have a more verbose description. You know, it's not very efficient, but you know, these microcontrollers are ridiculously fast. You know, this is running at 240 megahertz. You know, and we've got a megabit serial connection over ESP now. So I don't really care if it's that efficient. It doesn't need to be that efficient. We're just, you know, we've got tons of bandwidth and tons of space. We've got 16 megabytes of flash to store all of this stuff. We've got 2 megabytes of RAM. I mean, these are heavy duty embedded systems, and they send a lot of data. You know, they can handle sending a lot of data. So yeah, so that's basically a rundown of how you build a window for this system that can interact with the robot and get data back from the robot. I'll have a look now at the actual windowing system itself. And this is the biggest part of the whole system. You know, the windowing system is like 900 lines of code, but it has there's a lot of classes in here. So window chain is just a sort of a container class that keeps track of, you know, allows you to scroll left and scroll right and keeps track of what the current window is. It's very simple. Nothing complicated. The window manager is probably the most complex class. Well, maybe the touch manager might be, but the window manager is a pretty complex system. But you don't have to worry too much about this. It's a lot of complications to deal with, setting up timers for the screensavers and interacting with the touch manager and touch interrupts and all of that stuff. And none of that really matters to you who are building windows like this. You know, you have a window manager and you can register.
Are you intending to be sharing code, John?
Am I not? I am. So the window manager. So window chain is a very simple class. Window manager is a very complex class, and I'm not going to get too deep into the implementation of this stuff because it's really complex and you don't really need to know most of this stuff. All you really need to know is push window and push window chain. And push window, when you only have one window, well, it just pushes a window chain. It creates a window chain with one window and pushes it. It's very simple. And then pop window is the thing that happens when you slide up, but you can call pop window yourself as well if you want to like push a button to make it go away instead of sliding up. So there's a whole pile of stuff about adding the sliders automatically and scrolling, and then there's a whole pile of stuff about screensavers and callbacks and stuff, which, like I said, really aren't that important. The window is one of the objects that you really interact with a lot. And so you can think about this in a couple of different ways. The window has it has views, which we talked about earlier, and it has handlers. And you can register to get notified. You can register for when the window gets activated. And this is important. Like if you notice back in the RAWS window, in the run mission window, I don't bother with activation. I actually set up the timers and stuff like that in the class constructor. And the reason is because this is not in a window chain. If this was in a window chain, this wouldn't work. You couldn't do this way. Because it's a singleton window and you can't scroll sideways, and as I said before, anytime you flip up to to pop the stack, this window goes away and it creates a new window again if you go back into the run mission thing. So this code gets called. If you're in a window chain, so if we go back to the admin window, say, where you have a window chain, you'll notice that I had a, did I do that here? Init, main view, visual, blah, blah, blah. Register, click, build theme window. Yeah, sorry, there it is, window activated. So with this one, because it's in a window chain, when you scroll horizontally, it's not creating new windows. It's using the windows that have already been created. So you need to know when this window becomes active when you're scrolling horizontally. So that's why window activated is there. And you could use window activated in the telemetry mission run window as well if you wanted to. You know, you don't have to do it using the constructor. I just do it that way to show you an alternate method of handling it. You do have to use window closing though, in order to shut down things like timers. I just heard something go ding. I don't know if somebody's putting their hand up or anyway. I'm not watching the video screen, so if you want my attention, you have to say something. So anyway, going back to this guy. So we create this stuff in the initializer or in the activate method, and then we shut it down in about to close. We re-enable the screensaver, we de-init the update timer, and we shut down the telemetry system. Okay, and this kind of cleanup is really important to do because you don't want your telemetry system running when you're not on the telemetry window. You don't want your update timer running, and you know, you want the screensaver to work again when you go back out and things like that. So go back to, where the heck is window again? Window.py. Okay, so Windows. So you can register for activation. You can register for about to close. You can register for the screensaver activate and screensaver deactivate. And those are the same kind of things. If you're on a normal window that has a timer, like the URC, the very first screen, I want to get notified when the screensaver comes on so that I can turn off my timer. And by the same token, I want to get notified when the screensaver is shut off, like you can see the screen again, so I can turn the timer back on. So this is where you register for these things. And then the only other thing you really need to know about is add view. And the rest of the stuff is sort of internal to the thing. So views are really simple. Like I said, it represents an area of the window, and it has its own local coordinate system. Views can overlap if you want. You have to be careful about how you do that. And visual components are the really interesting part of this whole thing. So visual component is a big class hierarchy. Visual component is the superclass. So we have, and it just implements some really simple behavior. But visual label is something that draws on the screen. So origin, as we've said, can either be a rectangle or a point, depending on how you do it. And then it draws itself based on that information. You can update the text and the color using these methods, although they're kind of, you can think of it like they only, if you call set text and it's the same text as you called the last time, I don't bother redrawing because then the screen starts flashing all over the place and you don't want that. So you can call set text as many times as you want, as often as you want, but it will only actually redraw the screen if the text you're passing is different than what it was the last time you called it. And the same thing with the color, if it's not the same. Visual JPEG image you've seen, that just basically draws a JPEG on the screen in a view. So you could actually have small JPEGs and draw them in specific locations on the screen if you want little icons on your screen or whatever that are fancy graphics and stuff. Although it's very limited in terms of, when you display a JPEG, it overwrites whatever's underneath it. So there's no transparency or anything like that. A visual box is like a label with a rectangle and no text. And it just draws a box, literally, and whatnot. You can have it invert if you want. A button is something that you can see on the screen, so it's a box with a label, and you can push it, you can touch it. So when you set up a visual button, you want to register a click handler, and so with a optional argument. And the system has its own internal touch events, which you don't need to worry about. And basically it calls the click callback, which is the thing that you registered up here, when the person's finger lifts off the button. A drag button is a special kind of button, and these are buttons that you normally wouldn't use. Those are what I use for the scroll pieces on the edge of the screen. So for scrolling horizontally on the window chain and scrolling vertically with popping the window stack. So it basically knows how to draw them and handle drags and stuff like that. And like I say, you don't need to worry too much about any of this stuff. A list is something you can have. Right now, I've only got one list in the whole system, and that's the themes on the themes window. I just show a list of the different themes that are available, and you can create a theme really easily. It's basically just a JSON file. So it's a JSON file. It starts with the word theme. And so it has a name and it has a set of colors. And theme modern light, theme modern dark. And then, you can add your own themes. You can have 27 themes if you want. Can't imagine why you would want to, but you can also modify these if you don't like the default colors. You can change them. You can create your own theme and just change that. Set that as the default theme that runs. If you recall way back in the beginning, the very first thing that we do, the code does, is it reads the theme modern dark and then applies it. So if you want to change what the default theme is, this is where you do it. You basically read from a file. If you want to use the modern light, or if you want to create your own custom one, you'd create it and then you'd reference it here, and then that would become the default theme. So back to the windows. So visual list is basically, you can have more elements in the list than will fit in the screen, and you can scroll it with your finger if that's the case. And I did have an earlier video where I showed that in a much earlier revision of this code, but it's still there. It still works. Hold on. Sorry, I have a phone call that I have to take for 1 second.
Yeah, I understand phone calls coming in. I had one this morning myself.
Hello from Calgary.
Sorry about that. I'm in Toronto at an Airbnb and my kids are at home, and that was one of my kids calling. So, all right, back at it here. Let me share my screen again. And like I said, if you guys have any questions or comments or whatever, please let me know. So yeah, lists, you can have a bunch of items. You can scroll them by dragging with your finger. You can click to choose one, and it will become the sort of the selected item. And you can ask a list for its selected item. You can also double click, and that will call a click callback on the list that you can register for if you want. So yeah, that's lists. Roller lists are kind of funky. It basically, you can touch it and then drag to choose between different options. So it's just a different kind. It's kind of like a combo box sort of, but not really. I don't really like them that much. I mean, I implemented it and used it, but I don't really like it very much. It's such a small screen that it's hard to choose things from a list like that. A visual slider is like a horizontal scroll bar. You can drag it and have it set different values. So you basically just pass in a range, which can have a start, a stop, and a step value, and then you can choose one of those things. And you can once again register a click handler, and you know, you'll get notified when you select something, you know, select a value from the range. Visual Canvas is the last visual component that I've built. It's really interesting because it's basically a blank slate. So you create a visual canvas. Normally you create it on the whole screen, but you don't have to. You can create it. It's just in a view like everything else. And so you register a click handler and you register for touch events. And when you build it, you pass in a draw callback. And the draw callback allows you to draw whatever it is that you want to draw. So I have an example of this. I haven't showed it yet, but in the rover window, which is for my outdoor thing, I have a test canvas window. And I guess what I'll do is I'll show you that first. Let me just get to the right place here. So on the rover in mission configuration, if you push cone sets, it draws this picture. So this is basically a set of GPS coordinates, and I'll show you where those are in a second. And it basically scales everything to fit on the screen and draws a grid, and this is a 100-meter grid. And you can see the origin is like there's a thick horizontal line and a thick vertical line around the very first item, the first little circle. And that's the 0,0 location. And then it draws the other things. So that's all drawn using a canvas window. So, and we'll share my screen once again. So back here. So I have in this case, I have a set of GPS coordinates. So I've got cone names S1, 2, 3, and F, which stand for start, bonus cone 1, bonus cone 2, bonus cone 3, and finish. And then each of those gets its own GPS coordinates. So there's 5 labels here, and there's 5 GPS coordinates. And these are latitude and longitude. And if you take one of these and you punch it into Google Maps, it is in fact an actual location in London, where I live, in a park. So it's the corner of this soccer field, as I say, in a park. So that's that particular location. So each of these is a real location in that park. And so what I do in the rover window, in this particular thing, I'm basically building, I'm building a window, and I create a view just like that, create a visual canvas with the draw callback called self-draw canvas, and then I register the click handler click canvas, and then I add it as a component just like any other thing. And so we build the main window, we read the GPS locations, which I'll show you in a sec, and then we push that window, the canvas window, which is basically this. And so the actual drawing part is really simple. We draw the grid, and then we basically walk through the points, and we draw a line from this point to the next point, and we fill a circle with text, and draw the single label, which I've read from the JSON file, and display it inside the circle. The grid is pretty simple. We're basically, I don't bother clipping because, of course, you can display anywhere on the 240 by 240 canvas, including the corners that you can't see. So I just draw a horizontal and vertical thing. And so we basically have a scale factor that I compute when I read in the GPS functions, and that tells me, converts from basically the screen coordinates to the sort of a meter-based grid coordinates. So the space between each grid line is 100 meters times the scale factor, which then converts it down into pixels. So reading the GPS locations, we basically open this GPS01.json, we load it, close it, we get the cone names, and we get the GPS coordinates. So I just make a list of the GPS coordinates. I create a GPS coordinate object, which is a class that I created. It's in here. There's an awful lot of GPS code for MicroPython that deal with parsing strings from GPS sensors. There's virtually nothing that deals with computing distance and bearing and things like that. So I had to write all this myself. And this is based on some functions on it's called the Haversine formula for great circle distance and stuff like that, and bearing and distance between two GPS coordinates. It basically involves a whole lot of trigonometry. And so distance is computed in meters, and bearing is computed in degrees, and it's a compass bearing. And so I can build a method. I can build an instance of GPS coordinate from GPS coordinates with this latitude and that longitude, and boom, boom, boom. And it computes all of the south and west and north and east and all that jazz, and splits them out and figures out what they are, and etc. So going back to rover window here, I create a GPS coordinate based on those two values. Now these are numbers, so it doesn't use that one. It uses the constructor for the class, so it just sets latitude and longitude because I just pass them in directly with the sign set correctly and everything. So I just create a set of GPS coordinates, and now I want to convert or compute what the local coordinates are based on those GPS coordinates. So I'm basically going to, my first location is always 0, 0. It's the origin. The start cone for Rovo Magellan or Rovo Columbus is always at 0, 0. And then I'm basically walking through my GPS coordinates, and I'm getting two coordinates out of the set, and I'm computing the distance and bearing between those two. And then I create a location, which is a point, which is another class I created in this whole thing. So this is using polar coordinates. So you basically pass in a distance, and it's bearing plus 90 because we're converting from math-oriented bearings to screen-oriented bearings, which are a little bit different. And then I basically have all these locations now as relative offsets to the origin and to the start cone. And then I basically create a rectangle that encompasses all those guys, turn it into a square, basically, and figure out what the scale factor is. And it turns out on this screen, it's a 240 by 240 screen, but parts of that screen are not visible. But if you take a 160 by 160 rectangle and put it right in the middle, you can see the entire rectangle, including the corners. So I fit all of these GPS coordinates into a 160 by 160 square that's in the middle of the box, in the middle of the screen. And so I compute the scale factor based on that, and then I scale the box by that. I multiply all the values by that, and blah, 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 do all that, and I end up with local coordinates, which are in screen coordinate system. And then when I go to draw the canvas, I'm basically drawing those screen coordinates. And that's basically it for a canvas. It's I mean, this is a kind of a complex one because of all this GPS computation and stuff, but you can literally draw whatever you want, and you will get touch events when. And right now I just ask the canvas to redraw when I get a touch event, but eventually I'm going to extend this to do more interesting things. So yeah, that's the visual canvas, and it's simple, but it's very powerful, in that you can create, if you want to draw a map that's actually interactive, that you can touch and drag and whatever, if you really want to do that, well, you can do that, and that sort of thing. So yeah, it's that's the visual components in the windowing system. The only other part that I haven't really touched on is the touch manager, and you don't really interact with the touch manager as a user of this system, as a client. The touch manager basically interacts with the window manager and the visual components, and it has a bunch of things. It has a finite state machine that it's implemented based on when we get touch events, and when they're drags and when they're not drags, and when you lift your finger and whatever. So it's a bunch of code, but it doesn't really matter. It doesn't affect you, because you as a client register with visual components like buttons and lists and canvases to get like clicked and things like that. And so you don't have to worry about dealing with touch events, as it were. So that's basically most of the system. I think, I haven't covered telemetry yet. The telemetry class is really simple. I mean, it's ESP32. So you have to import network and import ESP-NOW. So in order to use ESP-NOW, you have to have a WLAN interface active. So we basically just create one, we tell it it's active. I don't know if we need this or not. I mean, apparently ESP8266s do. ESP32s may or may not. I don't know, and I don't really care. I just left the line in there. We build an instance of ESP-NOW, we tell it it's active, and we say, here's a callback when we get data. So when the robot sends us a bunch of data over ESP-NOW, call this function. And then we add the robot as a peer, and we created the MAC address when we created telemetry. So if you go back to Raw's window, when we create this run mission, remember we passed in Raw's MAC address. Well, Raw's MAC address is actually in secret.py, and it's just the bytes for the thing, and it's not really that big of a secret. It's just, I don't publish this in my GitHub, but it's now it'll be published in this video, but I don't really care. So it's basically the MAC address of the robot is the thing that you're talking to. And so you have to add that as a peer in order to be able to send messages. And I have a telemetry callback that you can register for, which, as you recall, we did, and set that. So when we get data from ESP Now, we basically have to pull it from the receive function, and the telemetry system calls process packet. And that's basically, I assume that a packet is a JSON thing. Eventually, I'm going to make this a little more complex, but right now I assume that I'm going to get a packet, which is a fully formed JSON string, that I can parse using load-s. And I'm going to have to add error handling to this, and I'm probably going to have to add something to stitch these things together if they end up being too big or they come across in multiple packets or whatever. That's all coming. I just haven't done that yet. So basically, once we get a packet, we call process packet. We call the JSON function load string with those bytes, and that gives us a packet object, which is really just a dictionary. And if the user has registered for a telemetry callback, then call that telemetry callback with that dictionary. And in RAW's window, we registered the get telemetry packet, which told the mission to process that telemetry packet, which, as you recall, is the thing where you have the dictionary. And so all of this data is telemetry data from the robot that we're storing in the mission object, which then ends up getting updated on the window at 10 hertz or whatever frequency you happen to be sending messages from the robot. And the only other thing you can do with telemetry is to send a packet. So we basically assume that you're passing in a byte array. So we send it to the robot with these bytes. And that's it. And then there's a shutdown function which deactivates both ESP Now and the WLAN interface. And so that's basically it. It's fairly simple. It's straight. This part, the telemetry part, is straightforward. It's only active while that one window is active. When the RAW's run mission window is created, we create the telemetry object and set it up and register for callbacks. And so then the robot's going to start sending us data when we, and presumably you'll set up your robot side so that when you send a packet to the robot saying, hey, your mission status is no longer paused, because this comes up in a paused state. So when you touch the screen and it switches from paused to not paused, it's going to send a message to the robot over the telemetry system saying, hey, you're not paused anymore. And that'll be basically notification to the robot to start sending telemetry data at whatever frequency it wants to send it at. And then all of this stuff will just happen. This stuff runs on a timer, the update window that runs on a 10 hertz timer. The telemetry updating the mission object happens at whatever frequency the robot sends the data over ESP Now.
And John, are you going to go through the robot side of this?
I haven't written much of the robot side. I mean, I have an example here of what I call a URC peer. So, I have this robot comms class, which has a telemetry object, and it's it's almost the same. It's slightly different because you don't pass in a robot MAC. And so basically what happens is the robot waits to get a message from the URC. And when the URC sends a message to the robot, included in that message is the MAC address of the URC, of the sender. Every message that comes over ESP Now you get the MAC address of the sender. And so if I don't have the return MAC set, then I set it. And I assume that there's only going to be one URC talking to this robot. And so I set it to be that value. And so now I add it to as a peer, and then this guy can start sending packets to him. But he has to receive a message first so that he knows who to send it to. And the reason I did it this way is because, I don't know if you guys recall, but I actually have two of these things. I've got a slightly bigger one with a much bigger battery, and then I've got a smaller one with a little tiny battery. And I want to be able to use them interchangeably without having to go in and mess with code. And so both of these are going to be set up exactly the same. So whichever one I happen to use to send the first message to the robot, that's the one that the robot's going to talk to. So this is a tiny bit different from the telemetry class that's on the robot, but that's the only difference is instead of passing in the peer, it figures out the peer based on whoever sends it the message. But the basic idea here is I'm assuming that your ESP32, like in my case, on both of my current robots, the ESP32 is just a pass-through. It doesn't actually do anything for controlling the robot. So it in the case of Roz, my quad walker, the ESP32 talks to the Raspberry Pi Zero over a serial port. And the Raspberry Pi Zero is the guy who does all of the robot stuff. And in the case of my Robo-Magellan robot, once again, the ESP32 is talking to a Pi board, an STM32 board, and it's also connected via UART. So I'm going to use a setup like this, where I basically have this robot comms, and the robot, which in this case is either the Raspberry Pi or the STM32, is connected via UART. And so when I get a command over telemetry, I'm just going to forward that to the robot. So basically, sorry?
Is this a different repo? So I pulled up
If you go back,
Yeah, I've
so
got URC
peers.
but it's only got two files in it, main.py and telemetry.py.
Yeah, well, this is main.py and that's telemetry.py.
Oh, I see. Yeah, I didn't see sorry, I missed the indentation. Yep, got it.
Yeah, so this is the only code that'll be running on my ESP32s.
Yep, got it.
Now, if you are using an ESP, like if you have a robot that is controlled by an ESP32, then your main.py is going to be very different from this. But this is how I would use an ESP32, basically as a pass-through. It basically enables ESP now on any other microcontroller or microcomputer, like a Raspberry Pi. So it provides a Wi-Fi based, ESP now interface over a serial port.
Yeah.
And so from the URC to the robot, we get this command callback. So when the telemetry system gets a packet from the URC, I basically just forward that directly to the robot. And when the robot sends data over this serial port, over this UART, I basically have this update function. And if the UART has anything in it, then grab the bytes and send them as a packet over the telemetry comms. And that's it. It basically just sits in a tight loop and does that.
So raising hands does no good. You have to speak up.
Yeah, I'm
Okay.
I'm looking at the editor here, not the.
Okay. John, a while back you were talking about, well, you had two URCs and
Yep.
You wanted them to talk. Why wouldn't you just, if you wanted to talk to it why wouldn't you just register both peers on the robot?
I mean, you could do it that way too, but then you have to send everything to both of them all the time.
Well,
which is
if one of them's not being used, it's not going to do anything.
Right. But
You don't have to. Otherwise, I mean, it just says that if these peers are available, it's going to send it to.
yeah, and that's another perfectly valid way to do this. If you want to do it that way, there's nothing wrong with that.
Okay, I just wondered why you didn't do it. It's okay.
Yeah, I wanted to make it flexible, so that if I get a third one or a fourth one or whatever kind of thing, or it just handles it.
Okay.
Now, I mean, this also allows anybody else to have, if they have a URC and they happen to know the MAC address of my robot, they could hook up their URC to it, and control it, and that's okay. I'm okay with that.
Yeah.
So.
All right. That was one of the questions. I just wondered why, and that was all.
I also just wanted to chime in that, first of all, this has been fantastic. This is Patrick. And one of the devices I found this week on a different project that I was doing it's a ESP32 to USB dongle. It's literally a USB little dongle that you can plug into a USB port, and it's got an ESP32 on it.
Right.
And it seems to me you could use the ESP now to literally send things through a USB port, as opposed to having to wire up a UART or anything like that, and even get it to emulate keystrokes and things like that.
If you're connecting to something like a Raspberry Pi, then that's a perfectly reasonable thing to do. Now, in my case, I'm only connecting the ESP32 to the Raspberry Pi on ROS, and ROS has a Raspberry Pi Zero, and I use the USB port to control the servo bus. So I don't have an extra USB port without adding a USB hub, which I really don't want to do. I don't have another USB port to plug in. So that's why I'm using the hardware serial port on the Raspberry Pi Zero to talk to the ESP32.
Yeah, I just wanted to point out the existence of the thing because it's really, really cool. I have one other question and then I have to go.
Sure.
In your in the window manager and the stuff that you're doing with the screensaver, there's nothing wrong. I mean, the way you're doing the screensaver stuff it certainly works, but it seems to me like, could you have just had the screensaver push another blank window that turned off the screen onto your stack, and then you pop it off?
Theoretically, yeah. That's an interesting idea. I'd have to make it so that it didn't draw the bottom slider in that case. But the other thing that I'm interested in with the screensaver is also power savings. And so I actually want to turn the display off and not just have a black screen. So I have to be able to, when you turn the screen off with the screensaver, the power usage goes from 80 milliamps down to 40 milliamps.
Right.
And that's significant for a battery powered device.
It looked to me, maybe it's not the case, but it looked to me like every window class needed to be able to know what to do for a screensaver.
No, some windows need to know. So there's multiple things happening here, right? If you have external resources that you've implemented as a part of your window, that needs to know when the screensaver kicks in or turns off, because you want to deallocate those resources and then reallocate them again. So from that perspective, that's what I call user code. It's not part of the windowing system per se. The windowing system needs to know because it's the guy who controls everything. And of course, the touch manager needs to know because the touch event from the touch manager is what triggers turning off the screensaver in the first place. So we have a timer that counts down from when you lift your finger. I start a hardware timer that's 60 seconds long, that if it doesn't get interrupted, when it triggers. It's a one-shot trigger. When it triggers, it switches the screensaver on. And, but like I say, there's a lot of back and forth with the screensaver, and I may end up looking at it and seeing if I can simplify it, because it is definitely one of the more complex parts of the system. It adds a lot of complexity. And as I said, though, it's not complexity that you have to deal with.
Right.
Complexity that I have to deal with.
Right. Well, I mean, I've been looking at this less from the I want to control a robot to, wow, this is a really cool windowing system.
Well, exactly. And this is a generalized windowing system. You can use it for whatever the heck you want. If you want to build a smartwatch, you can build a smartwatch. If you want to, have an IoT interface for your house, you can do that.
Right.
It's infinitely flexible. It's designed to be a general purpose touch-based windowing system, and there isn't any other of these available in MicroPython. I mean, Peter Finch wrote a really nice user interface system, but it doesn't handle touch. You have to use hardwired buttons, and I'm not interested in adding hardwired buttons when I have a touch screen. So yeah, I looked around and I didn't see anything, and so I built this. There's some nice stuff if you're using Arduino code on the ESP32 in C++, but I despise C++, so that just don't care that much.
Right. Anyway, I was very interested in it from the user interface perspective, and so that's where I'm likely to be hacking and playing with it. So it's really cool.
Yeah.
Anyway, thanks again. This has been brilliant. Absolutely worth the time to be here. So I appreciate it very much.
Question. Yeah, it's a fantastic system, John, and thank you for walking through it. It's much clearer. But are you going to put a bill of materials maybe in the GitHub with links to where you can buy that stuff?
I can. I mean, there's not very many materials that you need to buy.
I know there's like about two to three, maybe three pieces, right? The battery and the
power switch
and the
display,
and the remote, the little
well
remote.
yeah, if you're going to do the remote thing, then you need to get one of these connectors. And yes, I have a bomb in my system right here. Let me pull it on.
That would be my suggestion, is add that to the repo or put it in the
that's in the plans here, so I'll
thank you.
I'll
very, very nice and powerful system. Thank you for doing this presentation.
So
John, you might want to put the BOM in your README.
That's the plan.
That'd be a great place.
So this is the kind of the bomb with links of where you can get all this stuff for the cable and the printed parts and whatever kind of thing. So I mean, the batteries you kind of have to source yourself, and the battery plugs are kind of a pain because these batteries come with their own plug, and sometimes it's the right plug and sometimes it isn't, and whatever. But this is an example of one place where you can buy that specific plug. And the power switch, this is not the power switch I use, but it's one that will work. It will fit in the space, and so on and so forth. So yeah, I'm fully planning on adding this to the GitHub.
Awesome.
Yeah. I guess I should look at the chat since I haven't looked at the chat. Oh, hi, Joe. Yeah, Doug. So you've got yours running more or less. You're muted if you're talking.
What I did is I had started working when you had just before you had added telemetry. Okay.
Yeah.
So my intent was to modify this to introduce ESP now with the minimal amount of changes to your program. Otherwise, very, very essentially, I added the imports and stuff you need, and just one little function, and that way I could talk to I have two ESPs. I'm sorry.
Yeah.
One is acting as a sender, and I have another one as a receiver. But the receiver there is so that I actually have three ESPs in the system, and I just wanted to make sure that these two were talking to each other. And then I added the URC to it, and I'm using asynchronous communication, the asynchronous library, and you can look at it. It's if you go out to my fork out there, it's very, it's not much changes, and it does allow you to send data from a sender to your. Let's see if I can get this without tearing everything up.
And Doug, John, just a reminder that John asked that you explain again what once recording was going, how you organize Git so that you can make your own customizations to it.
I don't know if you can see this, but
Yeah.
there's the GPS satellites and the the rover voltage are changing, and all the sender is just changing. It's just sending random numbers basically, and it's just a test.
Yep.
And so I'm not saying this is completely debugged, but it seems to work well. And so that's what I'm doing right now. So if you just wanted to send data from your robot to the URC, it would work. Now, it's not near as elegant as what John's doing, and it probably won't have all of the nice features for it and everything. But I was just anxious to see if I could get something to work, and it worked. So, but my GitHub is Paradug. So you can look at it if you want to. And John, I think can't you look at any fork on your GitHub? Anybody's fork? I don't know if you might have to go to mine and see the fork. Okay.
Yeah, I'm not sure. I probably can.
Yeah, but what I'm saying is you can easily go to mine and you can see his fork. Which is actually it's MPY, I think. But I renamed his MPY to URC, okay, because that was the part I was interested in. And so you might have to go down a few directories, but it's there.
Yeah.
And then,
I've just got mine in a sort of a general purpose repo for MicroPython stuff. At some point, I'll probably build an actual repository for you.
Yeah, that would be nice.
Yeah,
but now you got. Then you're doing it this way. I'd rather you continue to work on it, and and worry about all the fine stuff.
Yeah.
So okay, Paul. So the here's how I did it. First thing you do is you go to John's GitHub. Okay, you go to, I think it's MPY, and then you fork it. Okay, there's a little button on the GitHub page that says fork. You get a chance to rename it, and like I say, in my case, I called it URC, but you could call it anything. All right, so you forked it over, then you clone it down into your local machine. Okay. Now, since John had made so much progress between when I did this and when he had, I literally had to step back. So I used a checkout, a Git checkout, to check out the proper version that I had on my computer, which you have to use. You can use Git log and find out, his list, and I just picked that out. So I checked it out, and then I made my changes to the local directory. Okay, I added the two. I only changed 2 files, so I changed those 2 files. All right, then you have to I did a add to get them ready for commit, and then a status to make sure everything was there, and then a commit, and then I do a status again to make sure, yay, verily, they're all ready to go. And then the first time you push it up, you have to use a git push -- set dash upstring origin, and then you have to have your name that you're going to call it, the branch you're going to call it. And you only have to do that the first time. After that, you can just use git push. Okay. And then I think that's pretty much all it is, because then it's up there. And so you locally, you make your changes, and then you, like I say, you add them to the commit, you commit them, and push them. And the big thing is you have to make sure you're in the branch then, because you don't want to write over the main.
Yeah.
You want to make sure you're in the right branch, so you have to select the branch.
Yeah.
That's pretty much it. So in mine, there's the main branch, which is going to be John's work all the way through, and I can update my fork. So all I have to do is, like, there's a button on the GitHub page where it says synchronize fork. You can hit that button and it'll bring up all this latest stuff. So then you'll have to push it down to your, I guess you pull it down into your local. Since I'm going to be working on the branch, which I call URC-DP, that's the one I'm going to be working on. To try to, if I'm going to do anything, it depends. Like I say, John's work is progressing a lot faster. I didn't think he'd have this much time to spend on it. So when he gets, I think he's real close. And like I'm saying, in my case, all I'm doing right now is sending data to the URC. I'm not sending data back to the computer. That's not a hard thing to add, I don't believe, but it's not. I just didn't do it because that wasn't what I was trying to do. But obviously, if you have a push button, you're going to have to send something to the robot to tell it to shut down. So you have to be able to do bi-directional communication. Yeah. But right now, this is so much further along than what I had on my, I was looking at Ray's chick magnet, and John, you're always going to be the chick magnet. So URC is cool, but in DPRG it'll be a chick magnet. So anyway, it's really nice, and I really appreciate your efforts on it. And this is as close as I've seen. It's like when you go out to do a 3D print project and you find on Thingiverse or wherever you get your files, and you find one that's really good. Usually you go, oh, that's crap. But these are really good. And this is what you've done, John. You created a really good project. I appreciate it. Cool.
Well, I'm glad it's been useful and helpful and all that jazz. One of the things I wanted to point out, and I didn't really make this explicit, but I assumed it was kind of obvious. These 3 classes, or these 3 files, ROS window, Rover window, and TT robot window. TT robot window doesn't have anything in it other than just drawing the robot. These are what I call the user windows. And that's the code that you will replace with your own stuff. And, I'm going to keep working on these ones because these are my robots. But the idea is these are the only pieces, and you need to change main so that it picks up the right pieces. But other than that, that's the only thing you should have to change. on this. You know, a little bit in main here, you know, if you want to display a different startup picture, and, you know, you're going to create your own windows for the window chain, and you might make your own theme, but you shouldn't have to change any of the other code in the system. And like I say, you'll build your own versions of these for your own robots that you know, do everything that you need it to do. But this code is not, I mean, you can use this as a template, as an example, which I assume is what you've done with the Rover window. But it's, you know, it's just an example of how to do this. It's not, right. Yeah. The intention is that this code is the stuff that you change.
Yeah, I only had to make changes in main and in, I think it was a Rover window. If
Yeah.
Might be Rover. Is it Rover window or Rover chin?
Yeah, it's Rover window.
Rover window. Those are the only two, and they were minor changes. They weren't, you know, probably less than 15 lines.
Yeah,
I just was trying to see if I could communicate.
Yeah, yeah. But I mean, if you're actually controlling a robot with this, then, you know, obviously the contents of those windows depend entirely on what your robot, you know, what kind of robot is and what it does, what sensors it has, what actuators, what missions you want to run with it, you know, that sort of thing. So it's really those are the files that you'll be changing in your repos. You know, I mean, you can change other files if you want, but there isn't really a need for it.
Yeah. So like right now, like I say, you're making so much fast progress. You know, this probably for me, it's probably going to drop down one, but because I got other things going on I have to handle.
Yeah.
But it was. You might look at the asynchronous to see if that offers any advantages to you. I'm just throwing it out.
Yeah. I've looked at.
I gotta go. Thank you so much for doing this, John. This is great.
Okay. Yeah. We'll see if I've looked at async, and it seems to add a lot of complications for stuff that you can do other ways.
Okay. All right.
And that may just be my lack of understanding. I've never actually used async IO in Python or MicroPython. You know, but as you can see, this system is very asynchronous as it's written. You know, it doesn't sit in wait loops waiting for stuff to happen ever. It's all event and interrupt driven. And I think async IO is kind of a front end to make it easier to do that sort of thing. But I don't know. Anyway, I've been writing code for a long time. And you know, back when I started, none of that stuff was, I mean, Python didn't exist when I started, but aside from that, you know, none of that stuff was there when I started my embedded career. So you know, I've always kind of rolled my own stuff.
Yeah. Well, it's cool. Like I say, I'm really impressed, and I'm hoping to use it. I want this to be the robot I'm targeting as my Robo Columbus robot in the
right.
That's what and so the next thing that have a little bit concerned about, and I don't know because I don't have the experience, is range. You know, I'm generally pretty close to my robot. You know, you know,
from what I've seen it, and there's a bunch of YouTube videos out there. I mean, I haven't done any tests at all.
Yeah.
Based on, you know, this board with what the chip, you know, it's got a chip antenna on it and stuff. But, you know, with two ESP nows that have normal antennas, you can get 150, 200 meters of range, assuming there's nothing, you know, line of sight.
Yeah.
You know, and if you're running a Robo Columbus robot and it's not line of sight, you've got bigger problems.
Yeah.
So, you know, I mean, I wouldn't expect you would be more than 10 or 15 meters from your robot at any point in time. And I don't think it will have I don't think it will have any trouble at all with that kind of range,
Yeah.
especially if the robot has a reasonable antenna.
Yeah. That's a good point. And then, like I say, the next thing I guess also that would be interested in, I don't know if I want to use this as my kill switch. Right now,
Yeah.
I'm leaving that open. You know what I mean?
Yep. Oh, you can. Absolutely.
Yeah, you can use this kill switch, or I could use what I typically use, like a car RC thing, and
Yeah.
basically you squeeze the trigger, and when you let loose of the trigger,
Yeah.
it kills it.
Yeah. The reason, one of the reasons why I built this in the very first place, because I looked at that as an option,
Yeah.
is I don't want the battery to die halfway, the battery for the remote to die halfway through a mission. You know, this for me, like Robo Magellan or Robo Columbus, is something that you do once or maybe twice a year if you're really lucky. And you get exactly 3 tries at it, and
Yep.
that's it. You know, if you screw up, then
Next
you know,
year.
because your battery dies, then yeah, you're waiting another year before you can do it again.
Yeah.
And so I want to mitigate that possibility, and for me that means my handheld remote has to have a display so that I can display the voltage of the battery that's controlling the handheld remote.
Yeah.
And that was where this whole thing started. I had a big triggers thing with a big handle and a microcontroller in it and a battery and a little one of those little OLED displays. And that was the whole idea behind this, was that so that A, I can see that it's actually doing something, and B, I can see that the battery's not dead and that it'll probably have enough battery to get there. And that's kind of morphed into this as I started playing with the round screens and stuff. You know, there was always the decision that, yeah, I want this to work as a fail safe. So which is why, you know, I added the little connector with the 3 pins. And so, you know, and given that you can, you know, you wear this on your wrist with a, you know, I have a little nylon, if you print the case, it's designed to work with the 1-inch nylon straps, which you can buy virtually anywhere. And I use these little, a little flip cam thing for it. And so, you know, you wear it like a watch. And like I said, I've got the ring thing or the trigger thing, the handheld trigger thing, as the fail safe. And the important part is it's not something else that I have to carry. You know, because when I'm running around behind my robot, one of the things I want to be able to do is film it, which means one hand is going to be holding a camera. And that means the other hand has to be able to display telemetry and be the fail safe. And so it just comes down to how much you trust ESP now. And I'm certainly going to be doing a lot of field testing before I go into any competition with this. And at that point, I will either trust it or I'll fix it so that it.
Yeah, I really like the ring idea.
Yeah.
I like that because that gets it separated from the watch a little bit, so you don't accidentally just brush over the watch and trip the button.
Yeah.
And the other one is that it, like I say, it keeps your hand. You can theoretically use both hands still.
Yeah, and it also, I mean, it has to be for Robo Magellan and Robo Columbus. It has to be a fail safe. You have to be pushing it for that, so the screen doesn't work.
In Robo Columbus, we will allow you to have a pause button. Instead of you don't have to. You don't have to be holding it, but it, you know, it depends on. If that's not that in itself isn't necessarily a big thing to do. You know what I mean? You can change that.
Yeah, and I mean the ROS controller that I have on this for my walker uses, you know, you push to toggle the pause state, touch the screen. I mean, I'm aiming more towards the Robo Magellan competitions that are held in the Northwest, and with their rules, you have to have a fail-safe. So,
well, I'm not going to go there until I successfully Robo Columbus, and then when I'm there, then because my son lives in Seattle, so I have a double reason why I'd like to go there.
Yeah.
So anyway, and I also like to meet some of the people up there. I've seen them in meetings and stuff, but I haven't actually met them.
Yeah.
So anyway, I'm taking enough of your time. Hey, I want to thank you one more time. This is fantastic.
Cool. Does anybody else have any questions, comments?
I could pop up a quick question.
Sure.
The ESP now, that's range you were mentioning, is that because it's Bluetooth between the ESP now? And
it's actually not Bluetooth. It's I believe it's using the Wi-Fi stack. That's
a problem with other people being around with conflicting things.
I don't think so. I mean, it looks like, I mean, I looked a little closer at it, and it looks like you have to choose the channel, which is why I think it's using the Wi-Fi stack, because it uses from 0 to 12 or whatever the channels that Wi-Fi uses. So you pick that in the ESP Now code. You can choose. I mean, it defaults to 0, but you can pick some other channel if you're having issues or whatever. And I will probably incorporate that ability to pick the channel into the URC and go from there. So that's on the list, but right now I'm just defaulting it to 0 because that's what it defaults to.
Yeah, the reason I ask is because I have no real experience, but I've been told, like with your cell phone, when you're in a crowd, you got 0 Wi-Fi. I don't care how many bars you got. So it might be something to consider.
Well, and that's because normally that happens because there's a lot of people trying to connect to the same Wi-Fi router.
Right.
And in this case, you're not connecting to a router at all. You're doing direct messaging between two devices.
As long as it's not on the same channel, it shouldn't be a problem. I have no experience, so I'm just thinking it's something to test before you go live to a contest.
Absolutely.
And, the other thing before you started recording and Mike was online, he had said that he had trouble configuring his. Is that something that you had trouble with?
So no. So what he's having trouble with is getting an image, a firmware image of MicroPython. You have to have a specific firmware image to use this. And Doug, yeah, I wanted to ask you what Doug
Parody.
Where did you get your image from? Which image are you using? And you're muted if you're talking.
Let me see. I want to say that this was, I just used Thonny. I think that's how they pronounce it, Thonny. And
right, but you had to get Russ Hughes firmware if you didn't.
Well, no, it'll download. I can't remember exactly how. Somewhere in there's a way to download the actual package. It's real simple.
Oh, are you using the firmware that? I guess it depends on which firmware you're using. The firmware that WaveShare provides.
Let me see if it'll register it. See if I close this. So oh gosh, they use weird colors. MicroPython on 2023-1202 ESP32-S3 LCD module with ESP32S3.
Yeah. Okay. So it's got some specific thing.
I
don't
remember if I had to flash MicroPython on the circular thing or not. Now
yeah, you absolutely do, because it comes with an Arduino image.
Then I would go to WaveShare and see what it would be in their their wiki.
Yeah, just to be thorough in your GitHub README, you might want to explain those steps for.
Yeah. Well, what I'm actually going to do, I'm going to build a custom, like I've built my own custom firmware that runs on this. And it includes a few of the fonts, although not all of them, because I had an issue not like including the Noto Sans 32, but I do the other three. You can make them as what are called frozen modules and stick them in there, and then they get included, and you don't have to have the files in the file system. So I will, when I get home, because I don't have it on my laptop. I didn't build it on my laptop. It's on my desktop at home. I will figure that out and get the flashed firmware and make it available. Basically,
Cool.
I'll put it up on GitHub so that you
Yeah.
can use it for this specific device, because this device is a little bit different than the generic ESP32S3 because it's got 2 megabytes of SPI RAM, but it's not octal SPI RAM, it's quad SPI RAM, so it gets kind of complicated. But
Then the last question that I had, and you probably covered it, and I just didn't quite follow what you were saying, because you said you used invisible buttons for your touch capabilities. I'm assuming you can
I
lay out
do.
areas of the screen that you can see a button and like.
Oh, absolutely, yeah. So
things.
if you look at the screen, so
Oh,
you can see, there's 2 buttons there, and those are touchable. An invisible button is exactly the same thing. It just doesn't draw anything to the screen. You
Yeah.
still define an area where you can touch. It just doesn't draw anything. That's all. And
Yeah.
so if you go back to this page, to this screen, that has a big invisible button in the middle that doesn't draw anything, but you can touch it, and it.
Right. Just in case you want to send information to the robot to do something, you would be touching things.
Well,
Okay.
yeah.
I was going to say, I just checked it, and yeah, on their wiki, they have very good instructions. You have to download tool, I believe, there, and the actual Microsoftware version, and it's all pretty simple to do. So if you just follow the instructions on the WaveShare wiki for this display, you should be able to get the right macros, right Python, if you're having trouble.
Yeah. I'll drop a link for it in the chat here, if you guys want to see. And there's a if you go down that page on the left side, they have under environment setting, there's a MicroPython entry, and you can click on that, and that'll take you to how you can do this. That's not how I did it because I don't use Thonny, but you can certainly do it this way.
Well, thanks. That's all my questions I had. Very good discussion.
Yeah. And Mickey, the question you're asking in chat there, frozen modules are a MicroPython thing. It's not a Git thing. Frozen modules are basically Python files, source code that has had the source code stripped away and has been compiled down to bytecodes already. And so you can include those when you flash MicroPython, and you can access and run the code, but it's you don't need to include the file in your local directory. Yeah. Anybody else have any questions, comments, whatever?
So if nobody else is going to say anything, I'm lazy. I haven't typed on my screen to look up what's the cost of these things.
So $25 or something.
Sorry about that phone call coming in.
Yeah, just a sec. Here, I'll share my screen so you can see. I gotta find the screen. Oh, that's silly. Screen. There it is. So yeah, $22 US.
Want to make just one statement here. You want to make sure you get this one that he's showing, because there's several versions. Some of them are just displays. Some of them have an RP 2040 on them.
Yeah.
And this one is this. You want to make sure you get this one.
Yeah, I'll drop a link to this in the chat. That's the actual product. You can get it on Ali. You can get it, I think you can get it from Amazon, although it costs a lot more there. But I just buy it directly from Waveshare. And so the important part is that it's an ESP32S3 and it's a touch screen. That's the important parts of that whole thing.
And it should have the, like you see, there's a 6-degree IMU on it too. So
yeah,
we're not using that, but just so you know, you're on the right one.
Yeah, I'm not using it. You can use it.
Yeah. I don't need to have it turn on when I raise my.
Exactly.
Yeah.
Exactly. So, yeah. All right. So the one thing that I am using is I'm using 2 of the GPIOs from that board for the for this thing here. So this is a 3-pin connector. It's got ground plus 2 GPIOs, and so I'm using those 2 for the fail-safe connection. Let's see. Yeah, that's the same one, the one that Harry posted in the chat, the AliExpress version of this. $24.54, so it's a little more expensive, but it's sometimes easier to get. Just make sure you pick. Oh, it's 28. Well, that's Canadian dollars I'm seeing. Make sure you pick the one that has touch, because they sell one that doesn't have touch and they have one that has touch. And make sure, obviously, you pick the one that has touch if you're doing that. So, anybody else? Any other questions, comments, concerns? All right. Well, I guess we'll call this then. I'm going to stop recording. Boom.